Hey everybody, Mr. Judson here. So a couple things real quick. First of all, I accidentally made this incredible discovery on Tuesday, I guess, or Monday when I was making the videos. My family had too many things going on. We were overwhelming the Wi-Fi, and so I walked over to a school that I live close to, and I was able to upload our lessons in about 5 minutes compared to 3 hours at home. I don't know if that's just how good Tacoma's Wi-Fi is or how bad mine is. But at any rate, it's going to save me a lot of time. And so I was looking at the kind of what we still have left to accomplish, the amount of time that we have left in the school year. So I've talked about going to 3 days a week for a while now, and it seems like something always comes up where it prevents me from being able to do that. The fact that I can now upload these videos in about 5 minutes, it's kind of funny. I just go sit by the front door of the school and I'm able to connect into the Wi-Fi. So if you guys ever have trouble, there's something else you can do. Just take your computer and go stand by Wilson High School and you can upload or download or whatever. So anyway, starting next week, we will move to 3 days a week. And those 3 days will be Tuesday, Wednesday, Thursday. It's too hard for me to go Monday, Wednesday, Friday, because usually I start making my videos on Monday. So that'll be the plan. And I think we also need to do that because part of our schedule is we need to get a decent review in. We can't just do this Central Washington final without some good preparation for it. All right. So anyway, let's go ahead and push forward with what we've got for today. All right. So we talked about I think on our last lesson that the next thing we need to look at is solving trig equations. We've done a little bit of that, not a lot. And so what I need to do is I need to get some thoughts into your guys' heads. So for our entry task today, I just want you guys to solve each of these 3 equations using whatever method you can. And the goal here is just to get some ideas into our head. All right? You guys go ahead and give it a shot. All right, so let's see. The first equation here, I'm thinking try factoring first, see if it works. So if I make 2 factors here, remember you always want everything to be set equal to 0. Okay? Anytime we're solving and we see any kind of exponents, we want it to be set equal to 0. So this could only be x times x. Here I want to think what are 2 numbers I'd multiply to get 60 and subtract to get a 4. And so 6 times 10. I could subtract those and get a negative 4. So I'll make this a positive 6 and this a negative 10. And then we'll just double check. X squared, negative 10x plus 6x, that does equal a negative 4x. And negative 60 is what we get for those. So that means that x equals either a negative 6 or a positive 10. There's my answer. For number 2, I'm also going to factor this. And I want to think to myself, factor out a 3x from each term. Right? We always want to look for a common factor first. We didn't have that over here. I don't have the same 3 terms that I had here, so I can't really use that FOIL method. So I'll factor a 3x out of each. And what I'm left with is x minus 4. And so that means that either x has to equal 0 or 4. For number 3, so I would try factoring. This would be 3x times x. That's my only option. This could only be 5 times 1. And let's see, if I put the 5 here, I would have 15x and then 1x. I can't add or subtract those to get a negative 10x. So if I put the 5 here, I'd have 5x and 3x, and I can't add or subtract those to get a negative 10. So to me that says that this does not factor, and whenever that happens we have to go to the quadratic formula. So again, this is something we should all have memorized at this point, but in case you don't, it is this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You want to make sure you have this down. A lot of people think they do, and what they have is plus here instead of minus 4ac, or they're only dividing by a. They haven't got the formula down right. Pretty hard to use this with the wrong formula. All right, so negative b, which means the opposite of what you see there, that would be a positive 10, plus or minus the square root of b squared, that would be 100. This could never be a negative number, right? Negative times a negative is positive, or a positive times a positive is positive. Minus 4 times AC. A times C would be 15. All over 2A, which is 6. And now we just have to simplify it. So I'm going to get 10 plus or minus the square root of, this will be 60 right here. So 100 minus 60, that's 40 over 6. I have to make sure I simplify the square root. This would be 4 times 10. And so 4, the square root of that would be 2. 10, that would be 2 times 5. Neither one of those is a perfect square. And so now I look at this and divide all three of these outer numbers by 2 to simplify it. So my final answer is this. X equals 5 plus or minus the square root of 10 over 6. And it's interesting to me how often people write this down but don't really understand what they're writing down. I just know I did the formula and that's what I got, and there's my answer. So what we're saying here is, one of the answers is 5 plus the square root of 10, whatever that is, and then divide by 6. And the other answer is 5 minus the square root of 10, and then divide by 6. So if I did that on the calculator, 5 plus the square root of 10, so I'm going to hit enter. That way I get the numerator done first. And then divide by 6. I got 1.360. And now if I subtract instead of adding the square root, so 5 minus the square root of 10, and now divide that by 6, there's my other answer, 0.306. Okay? So this we would say is the exact answer. Remember, sometimes they do that, like on the Central Washington test, they'll ask for an exact answer. They want this one, not this one. If it doesn't say to give an exact answer, then either one of these is fine. But I just want to make sure that when we write this down, we know that if we punch this into the calculator, what we're going to get is 2 decimal numbers. I know some people are going like, well, yeah, Judson, what else will we get? But I'm pretty confident there's some people that don't know what this means once they write it down. Okay? All right, so our goal for today, really this is nothing new to us. We've done this before. What if instead of x, I had a trig function in all these spots? That's where we want to go with this. How would I solve an equation if there was a trig function here? All right, so here's a trig equation that we need to solve. And first of all, just a couple rules. The equation needs to be in terms of just one trig function. What that means is, like, let's say I have a tangent over here. That means I'm going to have to use the Pythagorean identity to change this to tangents as well. Okay? I need the whole equation to be in terms of just one trig function. I want only sines, only cosines, only secants, whatever. If that can't happen, I have to at least be able to factor the equation so that each factor only has one trig function. If I can't do one of these two things, then I can't solve the equation. So when I look at this, the only thing I see is a cotangent, so we're okay with that. Let's go ahead and just work through this first one together. So, if this would have just been 3x squared minus 1 equals 0, because that's the only x term, I would just try and get x by itself. So since this is the only trig term, I want to get that by itself. So what I'm going to do is I'm going to move this 1 to the other side and make it positive. I've got 3 cotangent squared of x. Now I'll divide by 3 because I want to get that trig function by itself. So a cotangent squared of x is equal to 1/3. And what we want to remember here is that when we're solving, we're trying to figure out what x is, right? And when you have a trig function and then a variable, this x represents an angle. So what I'm really doing is I'm looking for the angles on the unit circle that would make this equation true, right? In the end, I want to be able to say x equals some angles. All right, so now to get this cotangent by itself, I'm going to take the square root of the other side. So I've got a cotangent of x equals the square root of 1/3. And because I'm solving for something, I have to include that plus or minus out in front. And so let's see, if I try to simplify this square root, I would say that the cotangent of x is equal to plus or minus. The square root of 1 is 1, and then square root of 3, I don't know what that is. So I want to remember that a cotangent is the same as, excuse me, a cosine of x over sine of x. And so when I divide this, I'm going to get plus or minus 1 over square root 3. Remember when we said if you're trying to figure out what a cotangent is, when you go look at the unit circle, you only have to look at the numerators. Okay, so I'm not saying the cosine equals 1 and the sine equals root 3. There's some denominators in there. These are just the numerators, and the denominators would have canceled out. So now I need to go to my unit circle and try and figure out where this happens. And just to make this easy for us, for this first one here, I'm going to slide the unit circle into the picture. What we're saying is when I do cosine divided by sine, so that's x coordinate divided by the y coordinate, I've got a numerator of 1 and a numerator of 3. Right? So if I go back and look at this, all right, so when I look at the unit circle, remember, cosine is the x-coordinate, sine is the y-coordinate. I want to do cosine over sine and get 1 over root 3. And I'm only looking at the numerators. So this angle would give me a positive 1 over positive root 3. That's one of my solutions right there. Over here I get a negative 1 over root 3. That's another one of my solutions. Down here, I get a negative 1 over a negative root 3, so that it will be positive, so that would be another solution. And then right here I get a fourth solution, 1 over negative root 3. So if I was to draw a unit circle here, I know I'm looking for values where we're either positive or negative. Cotangent does the same as the tangent, so I'm looking for an answer in all 4 quadrants. And so we saw that this was an answer, this was an answer, this one, and this one. All right, so remember, we're looking for angles. So x is going to equal, this would be 1, 2, 3, the 4th tick mark, so 4 over 12 would reduce down to 1/3, so that's 1 pi over 3. This was the 4th tick mark, so 5, 6, 7, 8. 8 pi over 12. That'll reduce down to 2 pi over 3. And if I come around here, see this would have been 18, 17, 16 pi over 12. So divide by 4, you get 4 pi over 3. And then this one I believe is 5 pi over 3. There's my answers. Now, this would be true if we said we're working in the interval 0 to 2 pi. Parenthesis, remember that means we're not going to include 2 pi because it's the same as 0. If that wasn't given to us, what I could do is I could say that this angle and this angle are halfway around the circle from each other. So I could have said pi over 3 plus any number of half circles, which pi is half a circle. And then I would say this one and this one are halfway around the circle from each other. So that would be 2 pi over 3 plus any number of half circles. So remember, when I say that, okay, here's pi over 3, and then you go around half a circle, and then another half circle, and then another half circle, and then another one. If n happened to be negative, I'd go to pi over 3 and then go backwards half a circle, and then another half circle, and then another half. So this one covers both of these answers as many times as you want to go around the circle. This one covers both of those as many times as you want to go around the circle. Looking at today's assignment, I was just checking the book. Some of the time they say we're going to stick between 0 and 2 pi, which means we give this answer. And some of the time they don't say that, which means we want to give this answer. So we just want to make sure we're aware of those two. Okay, let's try another one. All right, so we're going to go ahead and try this one. Remember, our first rule here is the equation needs to be in terms of just one trig function. I'm looking at this and I see 2 trig functions, and so I'm going to have to figure out what to do in order to get that as just one trig function. You guys go ahead and try it. So I have 2 thoughts on this one. I could use a Pythagorean identity. I could change this to 1 minus a cosine squared, and that would be fine. Or I could move this cosine squared over here and divide, and sine squared over cosine squared. That would be a tangent squared. That would be in terms of one trig function. I always like to stick with sines and cosines if I can. I think in the long run it makes it just a little bit easier. And so I would probably go that route. That doesn't mean it's wrong if somebody went with tangent. If you started out by making this a tangent squared equals 3, keep on going that way. Let's see if we get the same answer at the end. All right, so my chicken scratch up here, I know that sine squared plus cosine squared equals 1. So if I move that cosine squared to the other side, then a sine squared would be equal to 1 minus cosine squared of x, and that's equal to 3 cosine squared of x. So now what I want to do is I want to move this to the other side and add it to this one. Got to do the opposite of what we see here. So when I add a cosine squared, I get 4 cosine squared of x equals 1. Then I'll go ahead and divide by 4, so I get 1/4 equals cosine squared of x. See, I'm trying to get that one trig function by itself. And now I'll take the square root of this. So a cosine of x is equal to plus or minus the square root of 1/4. And square root of 1 is 1, square root of 4 is 2, so this is really plus or minus 1/2. And so now I'm thinking to myself, where on the unit circle does the cosine equal, remember that's the x-coordinate, equal either a positive or a negative 1/2. So again, I would draw my unit circle, and since the cosine can be positive or negative, it means we're in all 4 quadrants. And so let me put my tick marks in here. Alright, so I want to pick the angle that looks like it's at the halfway point. And so that looks like it would be this angle. Over here, that looks like the halfway point. This one looks like the halfway point. And not so much, but that could be because my tick marks are off by a little bit. So we're getting the same answer that we got in the last problem. And notice how it doesn't say anywhere up here 0 to 2 pi. So that means I need to give all of them. Now since again, these are halfway around the circle from each other, I'm going to say this angle plus n pi. Now if somebody else said, I'm just going to write down this angle plus n 2 pi, and then this one plus n2 pi, and this plus n, that would be okay too. You can list all 4 of these and then write plus n2 pi. I just think it's less work to say x equals that angle right there, which is pi over 3, plus any number of half circles. Or it's going to equal this angle, which is 2 pi over 3. I'm just remembering this from the last problem, plus any number of half circles. There's my answers. All right, so once again, we've got 2 different trig functions. I want to try and get this in terms of just one. And so I'd probably use the Pythagorean identity again to change this over to cosines. You guys go ahead and give it a shot. All right, so 2, and then I'm going to put in 1 minus a cosine squared. Remember, we just did that on the last problem. So 1 minus cosine squared of x. I got to make sure that that 2 gets distributed to both of these. Okay, so I want to put that inside parentheses. And that equals 2 plus cosine of x. All right, so if I distribute that, I get 2 minus 2 cosine squared of x. That equals 2 plus a cosine of x. And so because I have exponents here and I don't here, I need to get everything on one side of the equal sign and set it equal to 0. And I think because I always want my highest exponent to be positive, I want to go over to the right-hand side. So I'm going to move this over here so it becomes positive. 2 cosine squared of x. When I move this 2 over and subtract it, I get 0, so those 2 things go away. Plus this cosine of x, and that's equal to 0. So as soon as I see this, I want to think just like this. 0 equals 2a squared plus a. So a is really what this trig function is. How would I solve this? I would factor an a out of each of those and then set each individual factor equal to 0. Right? I would say factor an a out, and so you get 2a plus 1, and so a would equal 0 or a negative 1/2. See, I want to think the same way with this. It's just that I have a cosine of x instead of a. So the cosine of x would equal 0 or negative 1/2. Let me go back and write that down the correct way. So I'm going to factor a cosine of x out of each of these. And then I've got 2 cosine x plus 1. And so if you're going to multiply this times this and get 0, either this whole thing has to equal 0, right? So the cosine of x has to equal 0, or the cosine of x has to equal a negative 1/2. Just like if this was 2a plus 1, I'd say a equals a negative 1 over 2. You could write this down. You could just say 2 cosine of x plus 1 equals 0, that whole factor. Now move that 1 to the other side, it becomes negative, and then divide by 2. So cosine of x has to equal a negative 1/2. And so now I just need to figure out where do those 2 things happen on the unit circle. So here's my unit circle. First of all, I want to know where does the x-coordinate equal 0, right? Because cosine corresponds to the x-coordinate. And so that would be here and here. So x has to equal pi over 2. We didn't say up here, pick an answer between 0 and 2 pi. So I'll look at this and say they're halfway around the circle from each other. So plus any number of half circles. There's the first part of my answer. And now for this one, where is the cosine negative? Well, that's going to be in these 2 quadrants. So I'll put those tick marks in. And so the x-coordinate would be at the halfway point right here. and here. We kind of seem to be stuck on these two angles. So let's see, this one was 2 pi over 3. But this time I don't have another answer halfway around. So from here I need to go all the way around the unit circle to get another answer. So plus any number of full circles. Or this one down here was, let's see, that was 18, 17, 16 pi over 12. That reduces down to 4 pi over 3 plus any number of full circles. So I don't know if you guys noticed this, but all of a sudden we're back into radians, right? The time that we deal with radians is when we're graphing or we're solving an equation. Those are like the two most common times. That's why I didn't call this, 90 plus 30 would be 120. That's why I didn't say 20 plus n times 180. It's just kind of automatic that when we solve equations we deal with radians. Alright, that's what we have for today. Let me get you guys an assignment. Alright, so we're on C11 now. This is page 396. We're going to do 5 to 23 odd. Don't forget, next week we start moving on to 3 lessons per week. We're going to go Tuesday, Wednesday, Thursday. I think the fact that I can upload the files a little bit faster if I go over to a school that I live close to, it makes it a little bit easier. Alright, so that's it. You guys stay safe. Have a good weekend. I'll see you on Tuesday.